Okay, so
I cannot count number of weeks of this semester. But anyway, so we are approaching the end of the semester. We have one more week next week before Thanksgiving, but we are going to have the Monday class, but not Wednesday class during the holiday. So then after Thanksgiving, we have one more week before finalism, right? That's the schedule what I know. So I'm going to find the finalism schedule. So that will be determined by the registrar office. And hopefully we can finish the normalization today. And I'm going to cover the. I'm going to skip the chapter 15. So I already gave you a lot of information about the database design part. Instead, I'd like to focus on the query processing and query optimization. So hopefully we can finish the query processing and optimization before Thanksgiving. Then we'll cover the some part of the transaction management and variable recovery and so on, such as the component that we have discussed before. Okay, so for your reminder, we'd like to make the database design better. So what is the idea of the database design? Then how can we judge whether database design is good or bad?
the idea is to store robot information to be called upon or saved.
So when we search the data, it should be easy and fast. Not easy, fast. Okay, that's our goal. Then the simple idea is if data are unique, okay, whether the entire row or something attribute, if the data are unique, so we can not very easy, not always easy, but much easier to find the random access. So we try to make our database design without such a redundant information. That is our goal. So whenever we find such a redundancy, there are different types of redundancy. Okay, so redundancy does not always mean the same value, but redundancy includes the structure. In terms of the structure, where the data structure are redundant, like the table inside the table. So that can be also redundancy. So if we can find such a redundancy, we can normalize the split or the decomposition. So that is the only solution to make our database better and better. So for that process, we talk about the normalization. The normalization is the process to make our database design better. So to reduce, to avoid any redundant information or structure. So for the normalization, we talk about informal way, so guideline. So first guideline is, you remember one table, the meaning. That's I think without taking this class, we know nobody wants to mix the different information in one big jar. So one table, one meaning. Then second guideline, less the null data. Null is the data structure to make our relational database model. Relation. Okay, relation is kind of a standard group of data, but sometimes some of the data may not have the certain specific information. To address that, we can use the null. But because of such a null, it may cause the performance issue, also the waste of space. So we try to reduce the null, the data. And third guideline is avoid any anomaly. Insert, delete, and update anomaly will happen when if database design is not good. Okay, in other words, redundant information. So we try to avoid such a thing. And the last guideline that we discussed is the join. When we join the table, if your database design is not good, in other words, redundancy, then the join may happen unexpected data. So try to avoid any such unexpected data. So this is a informal guideline. So everybody can understand this. Then how can we define such a normalization process formally? in other words, the mathematical way, then it will be perfect. The theory and we can use such a normalization process in our database design. So normalization is kind of specify the condition. So from the unnormalization form, a normalization form is just a bag of data. You can put any information, any data in one big jar. There's no data structure, nothing. Just one big. A lot of redundancy will be happen inside this unnormalization form. So this is one I'm going to explain how we can use normalization later. But one of the way of database design is you can use the normalization process. Just collect any attribute information as much as possible. Then apply the first normalization form. First normalization form focus on what? Attribute redundancy. Okay? So if attribute does not have first normalization form, does not allow composite, also does not allow nested, and does not allow multi-value. Okay, multi-value. So if we do not have this one, that is the first normalization form. No attribute level redundancy. So in other words, this is the same as atomic the attribute, right? So that is the relational database model that we discussed. So for example, in the previous case, so this one, if you see the first one, the department, but it has the delocations multi-value. Also, the second example is a department, but the delocation is a multi-value. So how can we address that one? Always, normalization process is a decomposition, or split, or segment, whatever. So separate, you can split. So that is the first normalization form. Then second normalization form focus on the key. So before that, we talk about the functional dependency. Functional dependency means, so we try to formalize. So what is the meaning? Okay, we know what is the meaning in dictionary, but in equation, what is the meaning? What is the meaning? One semantic meaning, student, professor, or university. So those are the same entity type. How can we define? In mathematics, using set theory, we can use a functional dependency. So x determines 1. If the y is determined by x, we can see the x and y has a relationship. It's the same meaning inside. Okay? Then the x is the group of attribute. Y is also group of attribute. In this case, for the functional dependency, you can find as many functional dependencies as possible. Instead, what we want is minimal functional dependency. Minimal functional dependency means only needed. Okay, not additional attribute left-hand side. Okay, for example, social security number plus phone number can determine other because we have a social security number. But what we need is only the social security number. Determine other attribute. At this time, this one is called prime attribute, and this one is called non-prime attribute. So in second normalization form, we try to remove any such a redundancy in terms of what? The prime attribute. So second normal form is called the no partial dependency. No partial dependency means, for example, if we have the social security number and the T number, determine hours. Also, it determines employee. It determines D name. Actually, social security number plus D number determine hours. Okay? And also, it determines employee. That's true because it has social security number. Also, D name. However, if we take a look at this one, social security number and the employee. Social security number determine employee. Similarly, D number determine D name. It's a partially dependent, partial key. Okay, which means there might be different meaning inside. So this one is a functional dependency, this one is also functional dependency, this one is a functional dependency. So no partial dependency, but there is partial dependency. So how can we make the second normal form from such a partial dependency? Split, always a split. So in formal way, split by meaning, but from the normalization process, split by functional dependency. So that is the reason finding functional dependency is important. The minimal functional dependency. In other words, this is called the whole key dependency. Whole key dependency. This is a tip. If you can find the single attribute primary key, or the attribute, so social security number, whatever the attribute you have, prime attribute is just one single, automatically second normal form. Why? You cannot have a partial because only one the attribute. You cannot have the partial. So when you have only the one key, one prime attribute, is automatically second normal form. Okay? Think about your database you create. A lot of table has ID, ID, ID. So ID is the single attribute. So if you do not have any other prime attribute other the functional dependency, it's automatically second normal form. That is the reason without understanding normalization form, we can design table without such a problem. Then the third normal form, we little bit speed up, was in a hurry the last time. So third normal form focus on the nothing but key, which means it depends on only key attribute. So which means if we have the social security number determine the employee ID, employee name, and something other information, and DNO and DNAME. So social security number determine the non-prime attribute, this one. However, we can identify DNO determine DNAME. Okay? At this time, this is not a prime attribute, but we can find the dependency. Okay? This time, A determine B, B determine B, C. So this one is called the transitive. So eventually, so A determines C, but there is another part inside the sub-dependency. So third normal form does not allow such the transitive. Okay? In other words, it's nothing but only key dependency. Determined by the only key, but this one actually determined by the another non-prime attribute. Okay, so this time, so this is called the transitive. So this is not in third normal form. So how can we make the third normal form? In this case, only solution is split, decomposition. We can take out this one as another relation, another table. That is the third normal form. So, as I mentioned before, if you believe that you are thinking normally, then you can even not design. You can do the normal real life. If you believe so yourself that you can do. So anybody can do the third normalization form automatically. Nobody want to mix such the different meaning in one. Not only table, but when you clean up your room, so you have the several box basket. So you don't want to mix all your stuff. First basket is for the database class. Second basket is for the old stuff. Third basket is for something like that. So that is actually normalization process. If any redundant information or the stuff, you want to split segment. So that is the idea of the third normal form. So we can quickly go over the example. We didn't have a time to do. So this one is the example of the third normal form. So let's see let's say this is our initial database design. So EMP underscore the DPT. So we can find the functional dependency, social security number determine this, D number. And actually D number determine D name, D number determine D name is the social security number. So we can decompose. This is not in third normal form. So we can find the transitive, the functional dependency. So solution, how can we make it? The third normalization form, decompose it. Then the E name determine this, and D number determine this. In high level, informal way, you can realize this one is for the employee. The right hand side is for department. Okay, so this is the third normalization form. So you don't have to, but this slide summarized the first, second, third. First one is the atomic key. Okay, atomic. The second normal form, whole key dependency, no partial. Third normal form, only key dependency, not the non-key dependency. Okay, so that is the third normal form. So then the one, let's take a look at another example, last. First question, is it the first normal form or not? Yes? How can we check? Each attribute. Atomic, 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 atomic. You can be careful for multiple. So no such a thing. So this is the first normal form. What about the second normal form? Second normal form is the no partial dependency, whole key dependency. For what? For non-prime attribute. So you need to identify what is the prime attribute, what is the non-prime attribute. First, the prime attribute. Property ID is underlined, right? It's definitely property. What about country name plus lot number? It's a prime or non-prime? It's also prime attribute. So prime attribute is not the same as primary key. So when we identify the key, first you can identify minimal key. Right? There are several candidates, like for example, property ID and country name plus a lot number, two candidate key. Both of them can be used for the key, but we cannot have the two primary key, only one of them. So we can select property ID usually 1 or 2 times in a semester. I usually don't get a call from call. So this one is a key and this one is another key. We can select one of them as a primary key. The other will be candidate key. So they are almost the same. Okay? The only difference is it's not selected primary key. So we can consider all of this as what? Prime attribute. Which means non-prime attributes are area, price, and tax rate. Each of them should be determined by property ID, also country name plus lot number. Okay? If there is any attribute which is determined by property ID, but not country name, the lot number, that means it's not. So there might be something. The redundancy, okay? All of them should be determined by this. So which means when you check the second normalization form, you need to check all prime attributes. Not only the primary key, but all prime attributes. So let's check. Area is determined by the property ID. And also area is determined by country name and lot number. And also price is determined by this one, the property ID, and the price is determined by the country name and lot number. Tax rate is determined by property ID and also determined by country name and lot number. So this is this is what? The second normalization form. However, if you see that this tax rate is determined by also country name. Okay? So partially determined by country name. So this is because of functional dependency 3. So FD3, this is not second normalization. So some of the students confused when you check the second normal form, only check the property ID. So this one. So there's no partial because it's a single attribute, the primary key. So automatically second normal form? No. You need to check the candidate key also. So there is a partial dependency. Country name determine tax rate. Okay, you need to check the candidate key also. So this is not a second normal form. How can we make the second normal form? Composition. So you can take it out. So FD3. So country name determine tax rate. Then finally, this is the second normal form, and also this is the second normal form. So this database is in the second normalization form. Okay. Then next one is the third normal form. Third normalization form, we need to check the transition. Okay, whether there is a transitive. There is no transitive. So this one is the third normal form already. But this one has the area determine price. So we do not consider this one as a third. So we need to address, we need to make it how? Composition. We can take out the area determine price. So that will be area determine price. So this one is finally third normalization. Okay? So third normalization form, no partial dependency, it's a whole key dependency. Then today we are going to see the one more normalization form. Is a little bit more strict version, which is called the ECN. So the name, this normalization form was found by the Dr. Code. C indicates the Dr. Code, EF Code, who proposed a relational model. B is his colleague in Stanford University, so it's a Bush. So Bush and Dr. EF Code, they both together find sometimes, even though it's a third normal form, but it produced the redundant information. Let's take a look at that example. So I'm going to use this example. So lot 1A, this is our database design. So we can quickly check this is the first normal form, and second normal form, third normal form. What about the third normal form? We have the FD1, FD2, FD5. FD5 is area determine country name. Area determine country name. Okay? So is this the third normal form or not? First, you need to understand whether this is the third normal form or not. Yes? No? What is the third normal form? It's only key dependency. Okay? Only key dependency for what? Non-prime attribute should be determined by the key, right? That is this one is non-prime attribute, but it is determined by non-prime attribute. So that is a problem. That includes the sub, the functional dependency. So that is a different meaning, redundancy. So that is third normal form. However, if you take a look at this one, country name is determined by area. It looks like so for example, property ID determine area, and area determine the country name. That makes sense. Area means the New England area, not New England, North America area. And the country name is the USA, like that. So area determine the such a country name. No? New England, yeah, New England. So if you, New England area, determine the country name, right? If you know the something area, you can define the country name. So such an example. But in this case, this one is determined by this and determined by this. Looks like the transitive. However, country name is not non-prime attribute. This is already prime attribute. So when you consider the third normalization form, non-prime attribute, for the non-prime attribute, it's only key dependency. So this one you don't have to consider. Okay? It's already prime attribute. So which means this is already third normal form. It's not actually transitive. One more time. When you check the third normal form, for non-prime attribute, it should be determined by only key, no transitive. However, here it looks like the transitive, like this. However, this one is already prime attribute. Okay? We don't have to find which one determines this. It's already prime attribute. It's already key. Okay? So this is not a problem. This is not a transitive. This is a third normal form. You don't have to decompose. However, everybody will be they're confused. Anyway, it's a transitive. So this kind of transitive is called a pseudo-transitive. Okay, fake transitive. Okay. Also, Dr. E.F. Code and the Bosch, they realize when you run the database with this model, it creates some redundant information also, even though it's a prime attribute. So it's called the pseudo-transitive. So BCNF does not allow such a pseudo-transitive. Okay. So what do you need the solution? There are several different ways, but we can easily take out the area, determine country like this. Okay. So then we have the property ID, area lot number, and the area determine country name. So always, if you are not sure, I'm using this one. I keep in mind that this A, B, C. So A is the key, and the B is the key. It's a prime attribute, prime attribute. Determine C, no problem, but C determine B. In this case, this is the BCNF case. So I mentioned several times, if you believe that you are thinking normally, you can do the third normalization up to. But that is covered the 90% like that. And then the other 10%, not exactly 10%, 9.9%, actually BCNF case. So you may have such a BCNF case. It's not easy. It's not the intuitively you can get. So such a pseudo-transitive case. So most of the database, 99% of the real database, they require the up to BCNF. So if you join the project team that are doing the database project, your project manager may ask, why don't you normalize up to the BCNF? Then you should understand such a BCNF. So any problem if I keep such a the pseudo-transitive in our database, first time you may not realize such a problem. Later, when we have more and more data, that may cause the redundant information. That, if you have such a redundancy, that may cause the performance issue. So this is a pseudo-transitive. The BCNF does not allow such a pseudo-transitive. So, what about this? This is data. There is no key we need to identify. So, student and course. Student name and course determine their instructor, right? So we can define the student and course as the key prime attribute. They determine the instructor, right? So Narayan database mom, Smith database Nabel, Smith operating system Amar, Smith theory Schumann. There's no didn't. Yes. So student course, the student and course determine the instructor. Okay. However, if you see this one, you may realize there are redundancy, database number, database mark, database number. So it's a multi section. Then also we can see some redundancy. the operating system AMA, operating system AMA, which means that it has this one, instructor. If you know the instructor, you can find the course taught by that instructor. So instructor determines the course. At this time, this one is a pseudo transitive. So it's in the third normal form, but not in descending. Solution, we can take out this part. However, there might be different way, as you can see. Student course determine instructor. Instructor determine course. This is one way. However, we can define course, instructor determine course. Yes, instructor determine course. Course and student. Course and student. This is the one we find. Student and instructor. Student and instructor is one. And student and course. Maybe possible. And also instructor determine course. This is one table. And instructor and student also possible. There is no general solution. It depends on the requirement. You need to check for example, in this case, the student is both sides, which means it's instructor and course might be important. However, if you take a look at this one, instructor is both sides. So, which means that you need to identify something course information through the instructor. And you'd like to identify the student through the instructor. Student and course are more important. If you really want to keep the all three, at the time, separate, separate, separate. And will be one, the table for each. As I said, the ideal case of the normalization is one by one by one, no redundancy. However, if you, depends on the requirement, you can, first time it's not easy. So I usually recommend to use this functional dependency for when you segment. Okay? But there might be different way. Is possible. So this is the normalization form. We have additional normalization form inside. Fourth normalization form and fifth normalization form. Fourth normalization and fifth normalization form use multi-valued, the column, and also join dependency. But which is very rare, and also it doesn't impact a lot for your performance. So it's an advanced level normalization, but I do not cover in this class. However, in case, just in case your database later looks like they have something problem whenever I join, then look up the textbook, such a fifth normalization or join dependency, and try to address that problem. Segmentation is the only solution. How to segment will be the issues later. Okay. This is a theory. So practically, the more important thing is experience you need to do. So intentionally. But before that, before we see the example, how can we use normalization in our database design? So far, first half of the semester, we start from conceptual level design. Enter the ER model, then convert it into the relational database and create the database. Okay. Then sometimes our database design purely depends on what? ER modeling. It's a data modeling. If we something missed, if we do not have such a conceptual level, the experience like the biological database, and we rely on a lot of semantic meaning of such an entity, right? Not from the data. So sometimes we miss such a dependency. So you can apply such a normalization process to make sure whether you have the redundancy one using functional dependency. So that's the general way how we are using the normalization process. But sometimes you can use the normalization process for your database design. How? You can collect all the information, as much information as possible. It's unnormalized. Then check attribute by attribute. If there is any composite, take out as a one relation, one table. If you have something nested, so you can take out. So then we can make the first normal form. Then second normal form, third normal form and B7. Then that will be like the decomposition, then that will be your database design. This is another way, but practically not easy. Think about how many attributes. The first project that I joined as a database administrator, so my project manager interviewed, and so I joined that team in the company, so in the IT department. Then his room has the 3 sides of the ER model. It's a print. And he said, I have the 2,000 table in a database 20 years ago. It's almost 25 years ago, something like that. This was a really huge database. And how many attributes? Many of them intentionally. It is true. So database designer and architect, they put the as many attributes as possible. Just in case later, if we need more information. So the column 1, column 2, column 3, even the for extra, for save, so extra the attribute will be created. So how many attributes? Probably 100,000 attributes. So it's not practically possible to use the normalization form for your database design. But the small database may be possible. Also, you can think about the nowadays big data. Big data even do not consider the schema, which means it's an unnormalization form. Put everything inside the one big storage, like the Hadoop. Then you can apply the programming, like the map reduce, find out what is the key of this data, what will be value of the data. Then distribute. That is the idea of the big data processing, and there are several databases that are based on such an idea, like the NoSQL database. HBase is one of them, and the more. Okay, then we can see the example. We can use a normalization form for the example. Yes, I think I already uploaded this one. On Canvas. This is the invoice. Interesting. Yes. So your customer gave you just one sheet of invoice. Then I need database. So first you need to design your database based on this one. It's not the huge size of database design. It's just one sheet of the invoice. So let's try to use the normalization process for what? The database design. Okay, the first step is find. Yes, which means attribute. So you can find any attribute that can be stored at the database. So keep in mind, what will be the candidate of an attribute? It should be variable. If, for example, if this one is printed, invoice, INVOICE, invoice itself will not be the attribute, right? It's a printed. So for example, DAT, no, but the date value, this one will be attribute, right? And also, here top animal hospital, at the name of the hospital. This is printed. However, if I'm the CEO of the group of company, so several different hospitals, okay? Then this name of the hospital can be attribute. However, in this case, probably this is one. The hospital is printed already. So, however, invoice number can be attribute. We don't know yet what is the primary key yet, so just find attribute. Then, what about the Mr. Richard Cook? It's a customer name. So we can keep as an attribute and address also and so on. Pen name, yes. Procedure, yes, different procedure. I do not have any pet, but if you have your pet, probably you know that sometimes it's harder than raising the baby. Then the amount and the total maybe, right? So if you remember the ER diagram that we create, the derived attribute, over, that is a derived attribute, which means actually that's not the value that the user create. Instead, we can calculate like the number of employee per department, like that. This is the same. It's up to you, depending on your requirements. Tax rate. What about the tax rate? 8% is a fixed. Well, how much is the CT? 6.5 sales tax.
I think it's 6.35.
335. 6.35. It's not every time change it. Probably change it, usually increase, but it's not changing. So we can use as a fixed value in a programming. Okay. Then also this can be calculated. Total can be calculated. Okay, based on the tax. So then we can finally have such a normalization form like the invoice number, and the date, customer name, customer address. You can realize the customer may have the bring the many pad, multiple pad, also multiple procedure in one invoice. That makes sense. So we can we are going to use the parenthesis to represent multiple. Okay. So this is our unnormalization form. We don't consider any other thing, just collecting the information. So check whether this is the first normal form or not. No, because of this one. It's a multiple. So we need to address that. Like the invoice underscore the pad, invoice pad will be separated. Oh, by the way. From here we can identify easily like the Darren did. So invoice number as the primary key. So any other attribute can be used for the key, like the candidate key, so on, minimal key. So I think the invoice number is here. Then, so invoice number determine invoice date, customer name, and the customer address. And then invoice number plus, because this one is an invoice, then the with segment. So invoice number plus pet ID. Pet ID is not here, but so as a surrogate key, artificial key. So we can create the pet ID. Even though pet ID is not in the invoice number to manage in a database, pet name probably a lot of same name, right? So really a lot. So we cannot use the pet name, so instead we are going to create the surrogate key, pet ID, then pet name, and procedure amount. So is this the first normal form? Yes, this is the first normal form. What about the second normal form? Second normal form? This one is automatically second normal form. Why? So one attribute, primary key. What about this one? We need to check. So it's all connected. So one, the primary key, composite primary key. Pet name determined by pet ID. Procedure determined by invoice number pet ID. Right? And then amount will be determined by invoice number and the pet ID and the procedure. So this pet information is a part of the invoice underscore pet. Okay, so it's not second normal form. Solution? We can take out the pet. So we can have the pet ID determine pet name. Then the invoice is the same thing, invoice underscore pet. So you can understand the meaning of that. This is a pet information. This is a general invoice information. This one is specific case of the information. Then, is it the third normal form or not? Third normal form is only key dependency. Can you find any customer name determine customer address. Maybe, let's hold. So maybe, because we need more information to determine functional dependency. But the customer name, maybe. And the invoice number, pad ID, procedure determine amount, right? Depending on the procedure, it has the different amount. So these two may be candidate for the third normal form. So in our case, the customer number determine customer name, customer street, the customer city. It depends on your application. Whether your application access the sub part of the customer information, like the address, or not, that we can separate. So we can have the customer number as the surrogate key and the separate. But here, procedure and amount is not separate, which means probably in this database there are not many procedure and amount. So you may allow such a redundancy. However, if you believe that you have a lot of such a procedure in your system in the hospital, like the 1,000, so you do better. Yes?
I noticed on the invoice page that the procedures were they had two of the same procedures, but the prices were different. So the amount isn't fixed on the procedure.
All right, in this case. So this one may not, so which means we need to keep. This is not the 22. That's a good point. I didn't realize that. So this is good point. So procedure is not the same amount, which means it's the size of the doll, right? When you grooming, so the big, the doll and the small, the doggy may be different. So it's different amount, which means it's not dependency. So we can keep. That's good point. Very nice. The procedure and amount. So this is a third normal form. Can we find any the BCNF case? Probably not. So this time, question, is this the BCNF or not? Yes or no? It's a yes. Why? We cannot find such a case. Okay, which means it's already BCNF. In case you find this case, we need to address. So this is one common mistake, the student. If I give the very simple, like only one table like this, is this the first normal form? Yes. Second normal form? Yes. But if I ask the multiple choice, first, second, third, like that, so student may be confused. This is already BCNF. If you cannot find the case, that is in. Okay. This is a problem. One time I asked not this, the database design is the third normal form, but not BCNF. I asked it like this. First normal form, second normal form, third normal form, and BCNF. So actually when I make the question, I expect this one. Okay, it's the third normal form. But automatically second normal form and first normal form is the true. So all these three are true answer. Okay? So first time I expect this one, the third normal form, but so next time I change. Which one is not? Okay? Then answer is BCNF. Okay? Automatically, because if third normal form is the answer, all the other will be answer. Like that. Okay, let's see another example. So this is an example of the BCNF. So we already collect all the attribute with the functional dependency. This is for shipping. Okay, so we have ship name, ship type, the voyage ID, cargo, port, and date. And ship name determine ship type. So, why don't you first identify the key? Primary key, candidate key, key. So let me write down the ship. Why don't you identify the key? Ship name, ship type, voyage ID, cargo, and the port date. This is our unnormalization form, and we can identify ship name, determine ship time, and the voyage ID determine ship name and the cargo, and ship name plus date, ship name plus date, ship name plus date, determine this one, determine the voyage ID and port. Okay. So what can be the, in this case, we identified the three functional dependency. In this case, what can be the key attribute, prime attribute in this case? Which means the left-hand side, the key attribute, candidate key should be determined all the other attributes. So for example, if you know the ship name and the voyage ID, okay? The ship name determine this one, voyage ID determine cargo. But to determine the port, we need the date, right? We need the date to determine the port. So ship name and the voyage ID and the date. Ship name plus the date determine the ship type and the voyage ID. Then voyage ID determine this. So we can use the ship name and the date, right? Can you understand? So because the ship name determine ship name and date determine voyage ID, right? Then through the voyage ID we can determine ship name, the and the cargo, right? So then we can determine everything. So ship name and date determine what? The ship type and the voyage ID and also port. Cargo can be determined through the voyage ID. Okay, so this one can be used for the key, primary key of this unnormalization form. So key is the ship name and the date. We can underline. So prime attribute is the ship name and date. The next one is it the first normal form? Yes, there's no the composite, no nested, and no multivariate. So all of them are atomic. So first normal form. What about the second normal form? Definitely, ship name determine only ship type. It's a part of key. So it's not in the second normal form. So what will be the solution? We can segment the ship information. Ship name determine ship type. So this is the shipping information. Ship name and date determine ship type, voyage ID, cargo, and port. But here we can separate the ship name determine ship type. And the other is a ship name date. Ship name date determine voyage ID, cargo, and port. Meaning of that is voyage. So we can create the two relation after segmentation. Okay. Then is this the second normal form? Ship name and the date determine voyage ID and the port and yes. So it's in the second normal form. No partial dependency. So this is the second normal form. What about the third normal form? This one is the definite third normal form. This one is voyage ID determine cargo. So this is the problem. So we need to separate the voyage ID determine cargo. So ship name determine ship type is from the previous one, and the other is looks like the port, so we can name as a ship port. So ship name and date determine voyage ID and port. Okay, so this is the third normal form. However, it still has the voyage ID determine ship name. So voyage ID determine ship name. This is a case of the ECNF. because it's a prime attribute. So it's not a problem for the transitive. However, if we consider this is the problem of the duplication, redundancy, so this is a case of BCNF. So what will be the solution? We can segment. So in this case, we can segment the voyage ID, determine the ship name like this. So voyage ID determine the ship name, and the ship name determine the ship name and date determine the port, and the cargo, the voyage ID determine cargo, ship name, and the ship type. So this is the BCNF case. Okay. So you can do the more practice with this, the quiz, and the so on. Please do. I'm going to use one of them, almost the same, not exactly, but almost the same for the final exam. Okay. For your practice. So this one is done. Then finally, query processing and query optimization. Okay. So I'd like to use the example before we start the query processing and query optimization. Anyone who is going to have a travel during the holiday or winter break, where do you go? California? And any other? Where? Yes. India. Is it travel? It's back to home. Homecoming. So when after I moved to United States, so sometimes there's a business trip. So most of the time is to attend a conference and so on. But mostly I try to travel with the family. Not always possible because of kids at the time. How can you reserve the ticket? How can you find the plan, the travel plan? What is the best way for you? Google. And Google Travel. So what do you use?
Sir, for Washington, Flixbuses are best way, sir.
And any other? I actually used a long time before Expedia.com. It was still Expedia.com, yes. But nowadays there are many similar websites. So I don't want to check everything. Instead of going to the Google and then check the nearby, the hotel or the tent. Mostly it's the best price. Right? So that's what I've done. So, but the problem is, so for example, I'd like to travel to California. Where do you go? The northern, southern? Which part? San Francisco, okay. Please say hello to my daughter. My daughter is in San Francisco. So the San Francisco asset, and you travel to Boston. Also, you travel nobody wants to travel to Texas, Dallas. So I decided to travel the 3 cities. So all of them are big cities in the United States. So I try to make a plan for my trip. So first thing is how many different cases of my travel plan. So let's take a look at each city. What kind of the way for the sightseeing of the city you can use? You can drive a car, okay, and rent a car and drive by yourself. But New York may not be possible. So I have an appointment for dinner in the Manhattan. When I check the parking price, is 3 hours is $67, $68 for 3 hours. It's a car. So you can use a bike and what else? Train, sightseeing, tram. You can use the tram or let's say the tram. Okay, and bus. One more. So that is the best way to travel downtown. Same thing. Boston, car, bike, tram, bus, walk. And the Dallas, it's not easy to work. So really, so even bike not, but let's say car, bike, the tram, bus, walk. So you can select one of them. You can select one of them. You can select one of them. How many different cases? So 5 times 5 times 5. 625. 125 different cases. You need to select one of them. Like for example, I'm going to use a car, San Francisco, and Boston, the bike, and the Dallas, etc. Like this. Even 125 different cases. And also, you need to consider which city you are going to visit first. And Boston first, then going to Dallas and San Francisco. Or going to San Francisco first, Boston, then to Dallas. How many different options? 9. 3 for the first, second 1. You can use a factorial. Do you remember? I just remind you heard because the first case you can select one of 3. And then 1 is selected. Second, 1 out of 2. And eventually 1. So factorial can be used. So there are 6 different cases, which means multiply by 6. 750 different cases already to decide. Like this. So your travel plan out of 750. However, when you travel to this, you may travel different option, right? From Boston to Dallas, you can take the flight or drive or train. Okay? Too many. Bus. Okay. Instead of drive the bus, let's say bus. Same thing between San Francisco and Boston. Same thing San Francisco and Dallas. How many different cases for each the move? So there are 3 different cases. Okay. Then 3 different cases. So how many? What combination? 3 times 3. 9 different. Okay. So multiply by 9. 6,750 different cases. Among them, you need to select one best. Or what is your criteria, main criteria, when you search the Google for your trip? Price. We need to consider the price. Somebody consider the star. So satisfaction, customer satisfaction, or somebody may consider the different criteria. Let's say the price. Okay, lower is the better. Among 6,750, you can select the one best one. So this is the query optimization. Think about it. This is the table. One table. When you access the one table, so we are going to select the one way out of this one. Think about it. We already know brute force. Read everything. We can use a binary search. We can use the binary search in case of order. Also, we can use indexing, B3 index, secondary, different types of index. So it may have, we will see, at least 2 or 3, sometimes 10 different options. And this table is the same thing, table. And also, when we access the multiple table, we need to join. How many different types of join? We will see, but the hash join and nested loop join and sort merge join. There are 3-4 different types of the join. Okay, for each case. So we already have the roughly when you join the 3 table like the select from A, B, C table where and the A, B join condition and the B, C join condition, usually over 3,000 different cases you have. Then the database query optimizer select only one out of 3,000. Best means what? In database? Fast. Fast means there you need to consider a lot of criteria, research criteria, memory, CPU, hardware, or network. But in our database, we are going to consider what? Number of ion. So because this is the most dominant, when we consider the performance, the ion, number of ion, not memory, is a persistent disk, hard disk drive or the SSD. It's a disk ion will be considered. The factor you can almost ignore. So when you make the trade, the plan for your trade, the price is dominant one. There are other things like the satisfaction but you can ignore only the price you can consider. Similarly, when you access the database many different ways like this, then query optimizer will select one fast, the root. So it's a routing kind of. Then also I didn't. Yes, here ABC is different from the BAC. Most of case, database query optimizer access the table from the last one to first. Okay. Then by considering this one, best means least ion. Then it's a huge difference. Think about why. Does it matter if I access A first then B, or B first then C, C first then A? So let's think about the extreme case. So we have one, so it's a kind of the example of the, I did my military service. In my hometown, military service is the mandatory, compulsory. So I should spend at least the 2.5 years, it's 30 months in a military camp. We have only total 45 days vacation, but the other days I should stay inside the camp, military camp. It's compulsory, it's mandatory. But there is the 6-week training course. So after 6 weeks, it's not allowed to meet a friend. It's not allowed even at that time, no cell phone. We didn't have a cell phone. Even I cannot call to the parents. Only one time allowed writing a letter. But at the last day of the training camp, so family can visit. But there's 1,000 of the soldier and 10,000 of family. So it's very hard to find which one is which, because the last day after we finish the training, so like the celebration, mostly the food, because in the military camp it's so horrible, such the food. But think about we have a family here, and the other room is the soldier. Okay, we have the 10,000 soldier, but only one family visit. So to find which soldier will be this family, the one way is first ask the military ID to the family. First visit the family and ask the military ID, then go to the next room, then call the military ID. Then we can find the match join. Another way is first going to another room where the 10,000 soldiers are there. Then first soldier, what is your parent's name? And check. No. Then second, no. How many times? If you are lucky, first, but if you are not lucky, 10,000 times call. So when you match one, and 10,000. It's a different. Which one is the first? Okay, it's an extreme case. It's a join order. So when you join two tables, it's the same thing. If table is called, the first table is called the driving table, and second table is the driven table. This is the same problem in the for loop when you are doing the coding, programming coding. Okay, so for loop inside the for loop, or while loop, whatever. The loop inside the loop. Okay, when you are doing the programming, mostly you are doing such a for loop using the array. Okay, when you have the, for example, two-dimensional array, which one will be outer the loop? Which one will be inner loop? A is outer loop and the B is inner loop, like that. Why? A is the pointer, actually. Point to forward, this one. So if you access this one first, it's every time you need to access the specific address, in and out, back and forth, back and forth. But if you access this one, then you can access the next, like that. So you probably learned such a thing, coding, the habit from your programming class. So similar database. So when we access it, if this one is a driving table, for each driving table, then if this one is small and this one is large, and also if we have an ID, we can save a lot of time. So that is the benefit of, that is what the query optimizer is doing. Then how query optimizer decide? Always number of items. So nowadays, such a query optimization is called the brain of the relational database management system. Each DBMS, the company, like the Oracle Informatics, DB2, MySQL, they do not release open the algorithm of the query optimizer detail. But roughly, we are going to see how they calculate this one to find the best one. However, when we consider this kind of I/O, sometimes fluctuated depending on the situation. Think about you are going to travel to the Manhattan. So going to the Manhattan, there are many different ways like this. Okay, but if you have an interview in the morning, I have a very important appointment for dinner. So I should be there by the 6:30. What would be the best way? The train, because train guaranteed. Okay, guaranteed the information, like the less than 2 hours. But I'm not going to take the train, so I'm going to drive. But it's risky. Okay, for database query optimizer, need such a guaranteed information. So how can we get such a guaranteed information, like the exact information about the travel, the way, collecting the data a lot. So DBMS, for the better performance of the query optimization and query processing, collect the data frequently and not out of date. So that is also required. Based on that, we are going to see this. Before we start, how many minutes? 2 more minutes. So SQL is also language, structured query language. Query processor first, process the incoming query. So such a query is based on the SQL. SQL is the language. So just like the many other program languages, all other program languages, it should be compiled. So compiler, any compiler, Java compiler, Python compiler, or the C# compiler, any compiler has this. The scanning, parsing, and validating. The scanning means check all the source code and extract the keyword and it's a variable like that. And parsing, whether this one satisfied with the syntax and parse. Then, even though syntax is okay, if they do not have the permission, like they cannot access the data, so validate it. So SQL also perform the exactly same as what the other compiler is doing. Then there is a scanning, parsing, and validating. And submit the compiled form. In Java, compiled form is class. Okay? In Python, compiled one is binary code, or sometimes it's a .pyc file, class file. Similarly, the SQL has a compiled form which is called intermediate form or binary form of the SQL. That will be stored at the memory. Okay? So this one will be stored at the memory. Why? Later for reuse. At that time we don't have to do it again. The query is almost similar because you click, many people click the same menu that create the same the query. So we store the process query on the memory. Then finally query optimizer find the fastest route to access the table. This is called the execution plan, like your itinerary plan. Okay. Then based on this execution plan and the DBMS access the data and return to the user. Finally. So this is the overall process how your query is processed by the query processor, and this part is query optimizer. So we are going to see details how query optimizer decide the route of to access the data next week. Okay. Any questions? You don't even start yet. Please practice your normalization. Okay. And also, I think it may be your homework. Okay. To submit the other part of the slide that I show you. Okay.